All right. So, we're in week 25. This is notes part 1. And we are talking about triangles still, which is cool because we know something about those already. And we are expanding our knowledge. So, for right triangles, we could use a squared plus b squared equals c squared to find the length of the sides. If we knew two of them, we could find the third. That applies only to right triangles. So let's write some stuff down here. So it's important to know that right triangles only is what the Pythagorean theorem applies to. But we're getting sophisticated, and so we can use what's called the law of sines and the law of cosines, and they'll be used for triangles that do not have right angles, which we call oblique. So, if you're listening, which hopefully you are, down here, would you write oblique triangles? Oblique triangles do not have right angles. So you could write that here, oblique triangles do not have right angles, and that will be good. So, in solving these questions, we can start with some general triangle, right? A lot of the times we don't know the exact shape it will be, so we just kind of draw a triangle that kind of looks like a right angle, but not really. So it's not supposed to have a right angle. And what we do, so this is just by convention to keep us organized, whatever side, so if this is side B, the angle across it we call angle B, so across the triangle. This is side we call A, and across from side A we have angle A, and across from side C we have angle C. So you'll notice that the lowercase letters are used for sides, so write that here, and the uppercase letters are used for angles, so write angles over here. So, in general, if we know 3 of the parts, we can figure out the triangle. And by the triangle, so you'll see questions where it says solve the triangle. And what that means is we're trying to figure out all the angles on all the sides. So we have 6 pieces of information that we need. And in general, if we know 3 of those, we can figure out the rest. The one case where we really can't is if we know all 3 angles, because we could have this little guy, and we could have this guy, and we could have this guy. And do you see how all those triangles have the same angles, but they're definitely different triangles? These are similar, so they have the same shape, but different size. So here you could write except for the angle case. So if this is looking a lot like geometry, that's good. You're doing some remembering. So this is going to look familiar. The ASA or the SAA or AAS, right? You can say these backwards and they mean the same thing. You probably remember there's no S in geometry. Ha ha ha. So, we know one side and 2 angles. That could be described as this, or 2 sides and the angle opposite one of those sides. That's the side-side angle or angle side-side, and this was that expression, there's no S in geometry, that was used for when you were proving congruence between triangles. So for those, we use the law of sines, and that's what this notes. That doesn't make sense. These notes are about, and then next up we'll learn about law of cosines. So this is just sort of general. If you're getting confused, do I use law of sines or do I use law of cosines? This describes when to use each. The law of sines says that the sine of angle A over side A will equal sine of angle B over side B will equal sine of angle C over side C. So there is our law of sines, and we're going to turn the page and work through 2 examples. Great. So if you're listening, would you please draw a little smiley face in the right-hand side of the paper. That's down there. Thanks, just so I know that you're actually listening. All right, so part 2, we have 2 examples. First example shows this little triangle, and notice how the angles, let's see, are listed with big letters, and the sides are listed with small letters, lowercase. So we're given 2 angles, and a side. So this would be the case of angle, angle, side. We're going to use the law of sines. Here's our formula for the law of sines. And the instructions just ask us to solve the triangle. So that means we are going to figure, so what this means is figure out all sides and angles. 6 pieces of information. So substituting in what we know, here's angle C, so we know this is side C. So we can say side C is 80.4. Angle C is 25 degrees. And what else do we know? We know side A. So sine of angle A is 20, and then, I'm sorry, we don't know side A. That's what we're looking for first. So notice how in this equation we have 3, this equals this equals this, but all I'm using is that side A and angle A and side C and angle C. This we've left out until later. It's all good. So we have a proportion, and after solving, so I plugged sine of 20 into the calculator, and I got 0.342, and sine of 25 was 0.423. So notice how this is sort of a general rule. If you use 3 decimal places within the calculation, so this is within, because if you round something and then you round it again for your answer, you can actually be significantly off, especially if you're taking the sine or cosine of that. So anytime I'm calculating something and it's not the final answer, use at least 3 decimal places as a general rule. So that would be over little a and 80.4. So we're going to cross multiply, so if you could fill in the blanks, this would be a times, so if you write 0.423 here, and then 0.342 here, and 80.4 here, we would then multiply and divide and end up with a equals 65.0. So you could write that here, 65.0. When you're solving these, look at the triangle, and the cool thing is a lot of times it'll make sense. So if this length is 80.4, does it make sense that this is 65.0? Sure, that's ballpark. If you got something like 1.2, you'd say no good. Or if you got something like 10,000, you'd be like, hey, I'm probably wrong based on the fact that that's 80.4. So we got 65.0, and it's all good. We still need to solve for angle B and side B. So we can write out the equation again, where I said sine of angle B over side B equals sine of angle C over side C. And you could have here, instead of using this information, you could have used this information, because we now know both of those. It'll give you the same thing. So what we end up with after plugging in, so let's see, this, oh right, we need to know the angle first. So from geometry, we know that the sum of the angles is equal to 180 degrees. So first, if I plugged in here where A is 20 and B is 25, I think that I got C equals, angle B equals 131 degrees. So what did I say? 20 degrees, 25 degrees, solving for B, and we get, that doesn't sound right. Oh dang, 131. I'm going to double check who typed this in. So 180 minus 20 minus 25. Nice work, Torville. So, yeah, that sounds better. 135 degrees. And when we go to solve for the side B, so let's see, I'll write this out, because what I had was obviously wrong. Nice work, Torville. So we can say that the sine of angle B over side B equals sine of angle C over side C. So to solve, we're going to cross multiply. And I'm going to type in, I'm going to do this times this, and then divided by this is actually going to give me b. So let's see. I have sine of 135. So you could be writing this down as I just talk it through. My hands are on the calculator, so I can't. So let's see. Sine of 135 times 80.4, and then divided by sine of 25 gives me 134.5. And you could try that just to make sure you're ending up with the same answer. But based on the triangle, does it look like that would be 134.5 if this were 80.4? Sure, sounds good. Okay, so one example of quote-unquote solving the triangle, meaning finding all the sides and angles. Alright, so next up, the question, all the question does is says this. Solve triangle ABC if angle A is this, side A is this, and side B is that. So this is the ASS, right? We have the angle and then the side and then the side, and this angle is not between those. So we have to pay attention to how the sides fit together. So let's just plug in and see what we get, and then we're going to look at this diagram and piece it all together. So substituting in, we say that the sine of angle A over side A equals sine of angle B over side B. And what I drew, so pretend we didn't know all this information, but you can basically just start and say something like A, B, C. Alright, and I could have written A, B, C, doesn't matter. Given that we know that this is side A, this is side B, and this is side C, we're using uppercase and lowercase. And then based on that, so it's just some random triangle, but you can write in your information. So that's why I got this 43.1 and the 186.2 for A, and then the B equals 248. We can talk about that later. So general triangle, plug it in just to help keep us organized. So if we solve, let's see, I'm using the calculator for this. Well, that we don't know. So again, I'm using 3 decimal places, 0.683 over, and hopefully I didn't make a mistake like I did on that previous question. It's a little early for me. 248.6. And then we cross multiply, and I think end up with sine of B is 0.912. So again, this times this equals this times this. So when we get here, before we use the calculator and get an answer, let's think about the unit circle, because pretty much all masters by this point. So here's our unit circle. And what this means, we have the sine of some angle equals 0.912. We know that the sine of the angle is the y-coordinate. So on the y-axis, 0.912 would be about there. Remember, this is 1. And there are 2 angles that have a sine. So this angle has a sine that is 0.912. And I'm going to pick a different color here, like that orange. And this angle also has a sine that is 0.912. So the angle in orange has a sine that's 0.912, and the angle in blue has a sine that is 0.912. So watch what happens when we just sort of blindly plug into the calculator. We know that the sine of the angle is 0.912. Therefore, the arcsine or inverse sine of 0.912 is the angle, and our calculator is going to tell us, oh, 65.8 degrees. And that's all good. The angle in blue looks a whole lot like 65.8 degrees. This angle looks a whole lot like 65.8. Did I say 68.5? I'm sorry. Oh, it's early. So this looks like 65.8. This looks a whole lot like 65.8, so that's all good. But you have to draw on your knowledge of the unit circle. If this is 65.8, this angle, the angle in orange, is going to be 180 minus 65.8. We'll draw that in orange. So that guy, 180 minus 65.8, and that will give us 114.2. So this looks, hey, that looks like 114.2. I'd believe that. So this is called the ambiguous case. Ambiguous case where, and this is from this is where that expression, there's no as in geometry, because you can't prove congruence because there's actually two separate situations that both fit this information. So this question would actually give us two different situations, one of which is the triangle is like this, and this angle is 65.8, and then the other situation is the triangle's like this, and and that angle is 114.2 degrees. So two answers for that question. 2 for 1 special. Ha ha ha. Okay, that's it for part 1. See you in part 2.